Hello, this is an informational video brought to you by Engr, Matthew Cusimano, Justin Forrester, Melanie Wells, and Tianqi Zhang from JM Engineering. Today we will be showcasing the steps necessary for mixing, casting, and testing concrete mixtures. This specific video will include concrete composites made with pumice and styrofoam aggregates, but your own mixtures can be comprised of any type of aggregate in any proportions that you choose. This video will provide a framework with which you can create and test your own samples. After you've established which aggregates you will use and in what proportions, you should be ready to mix your samples. To do this, the following materials will be necessary: 6 pounds of Quikrete concrete mix, 300 milliliters of water, your aggregate materials, plastic cylinders, weighing scale, 1 gallon size bucket, a trowel, a hammer, quart-sized bowls, and gloves. Your first step will be to weigh the empty cylinders that you will be using for casting in order to use this weight in future calculations. Following this, fill one cylinder to the top with each of your aggregates, then weigh each of the cylinders that were filled with aggregate. With the information from the last two steps, you can calculate the total weight of each aggregate in the cylinders by subtracting the mass of the cylinder alone from the mass of the cylinder filled with aggregate. This will allow you to do future calculations that dictate how much aggregate will go into your mixtures. You can now move on to making your baseline concrete mixture. Zero a scale with a gallon bucket on it, then fill the bucket with 6 pounds of Quikrete. After this is done, add 300 milliliters of water to the concrete and mix thoroughly using a trowel. It is important that the concrete is not too wet and that the moisture is consistent throughout. With a baseline concrete mixture created, you can now pack your baseline concrete samples using the hammer and trowel method. Do this by filling a cylinder, then hitting the top of it with a hammer and trowel. Fill up any space created after packing down, and repeat this process until the concrete is as compact as possible in the cylinders. Make sure that the top is completely flat with the edge of the cylinder. With this complete, weigh both of your samples with their cylinders and take their average weight. Now you can move on to your own mixtures. Our samples consisted of 21% pumice and 14% styrofoam. We measured 21% of the total mass needed to fill one cylinder with pumice and did the same but with 14% for styrofoam. You will then mix these amounts with the same average mass of baseline concrete that you calculated previously. Mix them thoroughly in a bowl. When your mixture is complete, pack the cylinders with the same method used to pack the baseline cylinders. There will be excess mixture left over from this step. Do not worry. Finally, finish up by weighing all of your samples with their cylinders. Put all of your casted samples in the cabinet for drying. You should wait at least 1 week to dry your samples before you test them. Next, you should clean your stations, disposing of excess concrete and waste bins, not down the drains. When your samples finish drying, measure the mass, height, and diameter of each sample for later calculation. The machine that we use to test our samples is the Forney concrete compression machine. This machine uses hydraulics and gradually increases the compressive force applied to the samples until they break. It measures this max load and displays it on the screen in pounds. The minimum applied force needed to register a load is 1,500 pounds. Your samples will be loaded into this machine and will be tested until failure. Record the maximum load displayed on the machine for all of your samples. You can use the dimensions of each sample to calculate density. Similarly, cross-sectional area can be used with max load data to calculate compressive strength for all of your samples. With this, you have successfully mixed, casted, and tested concrete composite samples and can decide whether they are successful in meeting the mechanical characteristics that you desire. Thank you very much for watching.